So it's an honor to be on this stage, and I hope that my talk will be interesting enough for you to satisfy your taste. So as you can guess from the talk title, we'll be speaking about Android Shell. And you should understand that this talk is not about Android SDK tools. We'll be talking about the environment that is available to you after you get directly on the device. The only SDK tool that we'll be using is Android Debug Bridge, ADB. And actually, let's use it one. After typing ADB shell, we'll get to the device, and we'll be exercising different commands that are available to us. So I'm casting the screen of my personal device, and I want to stress the point that the commands that we'll see during this talk are working on a regular user device. Because on emulator, for example, you have a huge power in an Android shell, because you run as a root user and can do pretty much everything you want. You can check whether your application is creating the files correctly, connect to the database correctly with the SQLite 3 client. And during this talk, we'll be reviewing the commands that can be useful on a regular user device. Before we start our exploration of Android Shell, let's make a small overview of what will be backing our operations in the Android Shell. When a device starts, Android starts a special process that is called system server. The system server exposes a few system services, like alarm manager service or notification service. When our applications run on our device, they use an API provided by Android SDK, and that SDK wraps the calls to so-called managers to interprocess communication that communicates directly to the services that run in a system server. And actually, there can be multiple different processes that expose different system services on Android. There are additional native processes like Keystore Daemon or Media Service, and different Android APIs communicate with different services exposed in different processes. What we'll be doing today is running shell commands. The clients that can communicate with these services but running as a shell user. As you know, every application on Android runs as a separate Linux user and is running in its application sandbox with the appropriate restrictions and a necessity to acquire some permissions. The shell user differs from application users in a way that usually it has some permission that normal apps cannot acquire. And that is why the clients that are available in Android Shell, like Activity Manager client or Package Manager client, often can do things that normal apps can't do. So let's start, and for the beginning, just a little play with available commands. So to list all of the available services on a device that are exposed by system processes, we can use a service command. If you type service list, then we get a pretty huge list of all the available services. If you take a closer look, you'll see that an alarm service is available, or notification service is also available. What I suggest playing with is the system service, which is not available through Android API. It's a special system service that is called status bar. Let's take a look at it. So it exists, But there is no Android API that allows you to control the status bar. However, the service exists, and it allows different Android components to control the status bar, collapse it, and expand. And using this service command, we actually can initiate those binder transactions, those inter-process communication, on a low level. I mean that when you call some method using Java API provided by Android SDK, it is then translated to some transactions, sending some code numbers that then initiate invocation of some method on the system server side. And we can ask this command to send a binder transaction to status bar service with code 1, which actually will trigger an expand method on the status bar service, and will expand that status bar. We, of course, can collapse. Animations are pretty good, and I like playing with this command a lot. But with Android Shell, we can not only have fun, we actually can use it for pretty useful stuff. And another command that we'll use a lot during this talk is dumpsys. I would like to know whether you have used dumpsys. I barely can see you, but please, if you have used dumpsys command, say I. Okay, then not a lot of you. But so in this case, I will briefly describe what this command does. Basically, every system service, almost every system service, implements a special dump method. In this method, all the system services print their internal state. Like alarm service just prints all the scheduled broadcast intents that it has to send in the future. Activity service stores the history of broadcasts sent or active services running. And so we can type dumpsys and then specify a service name that we want to get the state of. In this case, we would communicate with the maminfo system service. It's also a service that is not exposed via Android SDK, but it can give you a lot of interesting information. If you type it without any arguments, and give it some time, you will get a list of all the processes running on a device, ordered by the amount of memory these processes are using. As you can see, the Twitter application is currently on the top of this list, and we'll be using this app for demonstrations. But actually, this information is probably more interesting for system developers, not for an application developer. But if you type a package name after the maminfo, like com, Twitter, Android, you will get information about this particular process. Probably this information is not that readable, as, for example, what is exposed via Android Studio tools, but it can display the native heap. And it is probably the only way to understand how much memory in the native space your application is using if you use some NDK instruments. Because what you see in Android Studio is only Java memory, is only your Dalvik heap. And the native heap is not illustrated by the standard tools. So if you want to understand whether you have any memory leaks in the native space, as far as I know, it's the only way to get this information. If you scroll down a bit, we'll see also what databases are currently connected by the application. And in this case, we can see that Twitter app actually has a pretty big number of databases used simultaneously. If you wonder why it is not a single database, I don't know. But my guess is that it is maybe connected with the backup mechanism that Mateusz was describing in the previous talk. Another section that can be useful for you is asset allocations. Basically, everything that you get from the asset manager, like fonts or any other type of binary data that can be allocated with Assets Manager will be listed here. Some time ago, it helped me a lot to debug a strange memory leak. At least at that point of time, it was very strange for us. Application was rebooting. Actually, the device was rebooting after long use of application. And the issue was that we were growing our native heap space because we were allocating the typeface every time the view was created, instead of using a single instance of typeface. And finally, we just looked at this assets allocation list and saw that we make too many allocations of the same font. That helped to resolve the problem. Unfortunately, typeface documentation doesn't state clearly that it has to be single tone. So let's move on and play with the device a little bit more. Probably in your practice, you had a desire to test how your application behaves in low battery level conditions, like whether you properly react on low level battery and reduce amount of your actions and so on, or probably if you skip downloading new data if battery is low. The battery service allows to play with this. So if you type dumpsys battery, you will get a basic information about your battery. You see that you will see what type of charger is connected. In this case, it is USB. You will see the battery level 91 and the maximum value for the battery level 100. The type of your battery, its temperature is actually 26.8 degrees in Celsius. And we can not only see information about the battery, but we can also mock the data. So first of all, we'll unplug the USB charger with the command set USB 0. I'm not sure whether you see it, but now on a device, on a battery icon, we do not see a flash icon, which means that charger is not connected. We mocked the system service data. And now we can set our battery level, for example, to 5. You can see that battery server is now activated on my device. And do not forget to invoke the reset command after your game, after gambling, because until you invoke the reset command, the system service will not switch back to real hardware signals and will still think that your battery level is at 5 and probably will not properly shut down your device, and it will be required. Moving on, say I if you are using application services in your apps. I said say I. Good. So when you deal with application services, you probably want to understand whether it is started at the correct moment, but even more you are interested in whether the service is stopped at the right moment and is not anymore running, consuming the resources of your device. We can do this. We actually can do this using developer settings, developer options, not Android settings, navigate into the apps menu, navigate into running apps and see what services and what processes are running on device. But we can speed up this process and just use a shell command to understand, to communicate to the activity service and see what is running. Let's, for example, launch the Twitter app. Yeah, and now let's check whether at this moment of time any services are running. We can see that after activity is stopped, we still have Twitter application running this service, which is called async service. This shell is a bit cut, but you can see that there is an async service running. So basically, when I test my application and I understand that at some point my service should be stopped, I can just check it with the shell command instead of navigating to some application options. By the way, in this command, you can specify a special flag, -c, which means include all the possible client data. If you specify this command, you will see the client section in the output. And if you, in your service, in your application service, implement the dump method, the data that you dump there will be available here. So basically, you can make your internal service state available in this way and check it when you want with a simple shell command. And of course, automate it. As I said, there is not only dumpsys command in Android shell, of course. And there are several clients for system services running in the system server process. One of them is Activity Manager. You probably have used Android Studio feature that allows you to specify what activity to launch when you press a green triangle in your IDE. And it is a pretty cool feature because you can get straight to the point to this place that you can test, that you want to review. However, that tool is not flexible enough. You cannot parameterize well how you want to start your activity. With Activity Manager, you can do this in a very flexible way. For example, if I was a Twitter developer, I would be very interested in whether my app can handle Twitter HTTP links properly and display the tweet in the app when a link in the browser is clicked. So let me get the link. I have it. Here it is. And now let's try to start an activity that will display this tweet. We use Activity Manager client, specifying, setting the command start, which we will start an activity, specifying the link as the URI data. And we know that when a link is clicked in the browser, action view is sent. Action view. And category is browsable. Yeah, so Twitter developers do their work properly and react properly on the intent. So what is important is that you can use the Activity Manager client to start arbitrary some activity that you want to start. Parameterize it as you want. You can specify any extras for your intent. For example, if you can pass an ES command, specify key value, and it will become an extra in the intent, in the incoming intent for your activity. What is even more important is that you can type start service and check how your service is working, making your service to start. But you have to remember that your service must be exported. By default, all the components you declare and that do not have intent filters in your Android manifest are not exported, and Android shell will not be able to start them. Only your process can start them. But if you, for example, in your debug manifest, will specify that your service is exported, you'll be able to start with it with the shell command and quickly test your service. In the same way, you can send broadcasts, and you also can use this command to stop your application. You probably know that you can use developer options to limit the number of processes that are in background. And with the Activity Manager client, you can kill your application on demand. For example, at this moment, we can see that Twitter is running. You can see a record in the processes list. And if we invoke amq com Twitter Android, then the process will be gone. So you can kill your application on demand and check how it restored the state and so on. So now let's get even more fun. Are you getting fun? I hope. So if you use automatic acceptance of functional tests, then that probably makes screenshots. Then you can get more insights from your test, enabling displaying layout boundaries on your device, or for example, enabling hardware overdraw debugging. Usually we do it also using developer options and do it manually. But you can also automate this. Android provides a mechanism that is called system properties. Some of them are mutable. And actually, when we interact with the Android system settings UI, we are modifying these system properties. One of them is debug layout, which is responsible for giving a command to hardware render whether to display layout bounds or not. So to illustrate, we can, in Android shell, invoke the command that will enable displaying layout bounds, setting this property to true. And now, if we start Twitter application again, sorry. You'll see that now layout bounds are displayed. So for example, if you add this step to your test launches, you can automate this and do, for example, several launches. The first one without any options enabled, the second one with enabling debug layout, and get the screenshots with the layout bounds visible, and another launch enabling the hardware overdraw debugging, and get an insight about whether you overdraw too much views, and all this be automated. Talking about other available tools and other system services that you can communicate with, one of them is App Widget, which can be very useful for launcher application developers. If you design a launcher application, you probably want to support different application widgets. And sometimes it's a quite complex task to implement it properly using their App Widget Manager. And this command will allow you to see what widgets are currently installed, what widgets are available and displayed on a particular host in your application, whether you do not have any leaks. I probably will not demonstrate all this stuff to save you some time for a coffee break, but what I want to say is that you can get an understanding of what is available in Android shell, listing the system bin directory. You will see a number of binaries that are available for you and that you can run actually. And there is a lot of them. There are a lot of them, and they are worth to explore. There is a package manager client that can be used to automate granting permissions, which might be very useful for you also for test automation on Android 6 devices. For example, if you install an app on such a device, you can automate granting a permission to that app and do not bother of dynamic permissions model and UI that has to accept a permission. You actually also have a backup manager client that can be used to trigger backups and restores. So I hope that I convinced you that Android shell is worth to explore, and probably we will start using it on Monday. Thank you for your attention and your passion.
Okay, and we have questions.
Hello. Can you please tell me, is there any way to install an application from the Play Market from this shell or package?
So the question is whether you can use Android Shell to install an application from Google Play.
Yes, that's correct.
Well, if you download it from Google Play an APK, then you can use ADB install too. It's not actually a shell command, but you need an APK. If you manage to get it from Google Play, you're done.
Thank you for speech. It's interesting. I have a question about can we run the shell on the real devices? Yeah, and what district we have? I don't know. What border you? What we can do in the real device like that?
So everything I did in this presentation was done on a real device. Here it is.
Okay.
I was casting my screen from it, and all this stuff was happening on a real device.
Okay, and we must have a root device, yeah?
It's not a rooted device.
Okay.
It's a normal device.
Okay, for the continuous delivery, we can remotely run the command on the shell on devices.
Yes. It is a question more about how ADB can function. So ADB can work on a wired connection when you connect your phone via USB, but you also can configure a TCP connection. For this, you will have to connect it once with a USB wire, then run a command to configure the TCP connection, then you can disconnect the USB cable and reconnect using TCP and Wi-Fi network, for example.
Wi-Fi is good, but if my client's far away from me, like another country, I can run some commands to debug.
Theoretically, yes.
But in practice?
In practice, it will be a bit hard because you will have to basically map the ports and give an access. Ensure, for example, that your device has a static AP in that network, in that internal network, and then map ports to make this port available for the public.
It's like VPN, yeah, we can use.
Yes,
well, thank you.
Something like this, or port mapping net or anything.
Any other questions? Okay. Again, about Auto?
No cars.
Thank you for this insight into Shell. It was very, very interesting. I'll probably use some Shell on Monday. So my question would be, you showed how to change the battery level. So how do you feel about setting it to 99, 98 every few hours, and then after 3 weeks showing it to your iPhone friends that your battery level is like staying for a month?
It's a great advice. Yeah. I will do it. Yeah.
Okay, thank you.
Okay. There is no question. Yeah? Have? Okay.
Which devices we really can set like we did with the battery?
Could you repeat, please, which devices we can?
For example, if I want to change time the same way as we did with the battery, which devices we can control such way?
It's a good question. The answer is not that simple. Basically, you do not have a lot of documentation for all this stuff, but you have the source code. And actually, the knowledge how to enable layout bounds display with shell command was acquired just brought in the source code of Android code base. And as for changing the time, I don't have an answer in my hands. I have to check. Probably it is possible. I'm not sure. Sorry.
Okay. So
Hi, thank you for your speech, and I'm sorry if I missed something because I was a bit late in the beginning, but I'm wondering if there is a chance to set up some slow network connection condition.
Also a good question. It is definitely possible on emulator, but using the standard SDK tools and probably emulator command. I'm not sure about real devices, because on emulator it can probably be implemented on a lower level than communicating with some system services and binaries available for the shell. So also cannot answer, sorry.
Thank you.
Hello. I have a following question. As a tester, I am usually interested in gathering information about CPU consumption, memory consumption, battery consumption. Yes.
Mm-hmm.
When gathering CPU usage and memory usage is clear, but how IDP can help in gathering information about battery usage. Did you know simple solutions?
So talking about the battery usage, you probably know about battery historian tool. It works on analyzing the bug reports that you can collect with the ADB bug report, which actually dumps all the system services state and also dumps the event log. And then visualize how the battery was used on a device. And this battery historian tool is probably the best choice. If you cannot use it, because I cannot imagine why you cannot, but probably if you cannot use it, you can always see the battery usage history in event log. So the Android has 3 different logs in the system. One of them is logcat, that is available for applications. Another is a system log, which is like logcat, but this buffer, this log buffer, is not available to apps. And a third log is event log. It contains a record of different events that are happening in the system and actually describes all that happens in the system. And with logcat command, you can switch to this event log buffer and then filter for something like battery usage tag. And you will see different battery levels at different points of time. So it also can give you some insight about how battery is used. But battery historian tool is much cooler thing because it describes you what application was responsible for draining the battery and what components were draining the battery.
Yes, but problem is how to visualize logcat data. Best solution which I found require compilation of some program written in Go, running them, and after that it try to visualize. Yes, that whole process take me about half of day because of collecting knowledge how to compile Go program, solve problems with compilations and so. Did you know maybe some other ways to visualize such data or no?
Sorry, cannot help you with other ways. Probably we should improve the README file on battery historian to simplify the code program compilation.
Thank you very much.
Sure.
Okay, probably last question. Do we have last question? Oh, it was already? Last question.
On the right side.
Okay.
Is there a possibility to install an application from inside Android shell?
Yep. Using the package manager client, you can sideload your APK to on a device to some temporary location and then invoke a package manager command to install it. It is possible.
Okay. Thank you.
Thank you too.